Very well. The very first question says, determine whether the data set is a population or it is a sample. Remember that when we are talking about a population, we need to take into account every element, every number, every value. But when it comes to sample, we are working with something like survey. Let me use a different color for this. Survey, random. So here you have survey or random. Very well. So the very first one, it says the age of every fourth person entering a department store. Are we working with a sample or a population? It says the age of every fourth person. Because of the keyword fourth, it means that we do not take into account everybody. It's not a population. So what is this? It is just a sample because of every fourth person. Let's take a look at question 2. The age of each, okay. I found the keyword each employee at a local grocery store. Every employee is included, every one of them. It means that we are dealing with population. Let us move on to question 3. So for question 3, we have a survey. We have a keyword, survey. When we see survey, it means that we are dealing with a sample. We have a sample of 1,782. So, survey represents a sample. We have a sample of 1,782 American households. Well, you have a survey. In that survey, 80% of the households own a computer. So what is the sample? Sample is the survey of 1,782 American households. This is your sample. What is the population? Population is all American households. This is our population, all American households. Let's take a look at number 4. Number 4 says, when 1,886 American households were surveyed. Okay, guys, another keyword, survey. It means that you're dealing with a sample. This is your sample of 1,886 American households. Very good. Another sample for you. We found 85% of them own 2 cars. Again, when you're dealing with the population, population is again all American households. Number 5, we have a survey, keyword survey, representing a sample for us. A survey of 2,625 elementary school children. This is my sample. What is the population? The population is going to be all elementary school children. Population, all elementary school children. Very good. So let's take a look at number 6. Number 6 says, well, here we have use the Venn diagram. Venn diagram, it has some squares, it has rectangles, and it has some circles to represent the collection and sub-collection. Identify the population and the sample. So here it says, hey, in the whole collection, we have the magazine subscribers, all magazine subscribers. Inside this whole collection, you have a sub-collection, magazine subscribers who renewed their subscription. Well, question says, identify the population and the sample. Well, as you can see, the population is all magazine subscribers, all of them, all magazine subscribers. And the sample is just this sub-collection, which is here, the magazine subscribers who renew their subscriptions. So this is your magazine subscribers who renew their subscriptions. This is our sample. Let us take a look at second page. Second page says multiple choice. Choose the one alternative that best completes the statement or answer the question. Determine whether the data are qualitative or quantitative. Okay, guys, qualitative are the ones that have qualities, categorical data, like eye color, hair color, blood type. Quantitative or numerical. Well, like what? Like SAT scores, GPA, and things like that. Very well. The color of automobiles on a used car lot. The color, well, it says we are dealing with colors. Colors is categorical, so we are dealing with qualitative data. Number two, the number of, guys, this is the keyword for you. Wherever you see the number of, it means that you are dealing with quantitative data. This is your keyword. The number of complaints letter received by the United States. Also, you don't even have to read the rest of it. The keyword is the number of. As long as you see the number of, it means that you are dealing with numerical data. The number of. Number three, again, the number of. Hey, I have my keyword, the number of, so it means that I'm dealing with quantitative data set. The numbers on the shirts. The numbers on the shirts. Guys, it's not saying that the number of. There's a difference between these two. The numbers on the shirts of a girls' soccer team. These are just qualities, categorical. Qualitative data. There's a difference between of and on. The number of represents numerical. The number on, you have some numbers, some figures on the shirts. Very good. So let's move on to the rest of them. Very good. Question 1 says, a medical researcher obtains a sample of adults suffering from diabetes. She randomly assigned 67 people to a treatment group and 67 people to a placebo group. It means that some of them are actually getting the drugs and the other ones, they don't get the actual drug. The treatment group receives a medication over a period of 3 months. 3 months, it takes time. And the placebo group receives a placebo over the same time frame. At the end of 3 months, the patient's symptoms are evaluated. Are we dealing with experimental study or observational study? Remember that for experimental study, we have to have some data before and after the experiment. We are interested in comparing those before and after experiment. So you're dealing with experimental study. Question 2, it says a poll is conducted in which professional musicians are asked their ages. So you just walk around or you run a poll, you take a survey, and you just ask questions. We don't have any experiment here. We're just asking questions and collecting the data. It's an example of observational study. Well, the next one. A pollster obtains a sample of students and asks them how they will vote on an upcoming referendum. How they vote. We don't care when they vote, if they vote, not vote. We are not interested in making any changes in their opinion. We're just asking the question, collecting the data, observational study. Very well. The personnel director at a large company would like to determine whether the company cafeteria is widely used by employees or not. She calls each employee and asks them whether they usually bring their own lunch, eat at the company's cafeteria, or go out for lunch. Just asking questions, just observation. So it's an observational study. Next one, a scientist was studying the effect of a new fertilizer on crop yield. She randomly assigned half of the plot on a farm to group 1 and the remaining plots to group 2. So we have 2 groups here. On the plots in group 1, the new fertilizer was used for 1 year. Guys, it took a whole year. On the plots in group 2, the old fertilizer was used. At the end of the year, the average crop yield for the plots in group 1 was compared. We have a comparison here with the average crop yield for the plot in the group 2. As you can see, this satisfies all of the criteria for an experimental study. Let's go to the next page. Well, on page 3, what do we have? Page 3. Question says, use the frequency distribution to find the following. Well, okay. Let's take a look at the first question. The first question says, here we have the height in inch. You have the class, you have the frequency for each class. The first class starts at 50 and stops at 52. You have frequency, which is 5, 53 to 55, 8, and the rest of the data in the table. Question says, hey, what is the class width? How do we find the class width? What was the definition of class width? Class width was the difference between the lower bounds of classes. So you can say that, hey, 53 minus 50 is equal to 3, and I have my class width between these 2 lower bounds of consecutive classes. Class midpoint of the first class. To find the class midpoint of the first class, we're going to take 50 plus 52 divided by 2, which is equal to 51. This is the midpoint of class 1. Very good. The next question says, class boundaries of the first class. Remember that for the class boundaries, we shift the class half to the left, half to the right. So for class boundaries, shift to the left and to the right. So this is the shift. So take a look at this class. It starts at 50. So we're going to shift 50 half a unit to the left, which is equal to 49.5. Then we're going to shift the upper limit 52 half to the right, which gives us 52.5. So the class boundaries, you need to see a shift. If you don't have class boundaries, then you have gaps between these classes. Then you don't get a histogram. You get a bar graph, which is wrong for a numerical data. So the correct answer is A. Very good. Let's take a look at question. Very good. Let's take a look at question 2. For question 2, the same set of questions. What is the class width? Well, the difference between the lower limit of consecutive classes. You can say that, hey, 12 minus 8, which is 4. So it gives me class width. Okay, now the next is the midpoint of the first class. Okay, the midpoint of the first class, I get 8 plus 11 divided by 2, 19 over 2, or just 9.5. This is our midpoint of the first class. Then we want to find the class boundaries of the first class. Again, for the class boundary, remember that you need to do a little bit of shift to the left, to the right, shift to the left, to the right, half a point, just a half. So 8 to the left gives you 7.5. 11 to the right gives you 11.5. So the answer is A. Always shift half unit to the left, half unit to the right. So the bars get adjacent to each other. They have no gaps in between them. Number 3. The same process, the same question set. So to find the class width, do the subtraction. It doesn't matter which 2 consecutive classes you're taking. You can subtract 155, 150, or 150, 145, 145, 140, 140, 135. All of them are equal to 5. So to find the class width, 140 minus 135, which is 5. This is our class width. Now I say, hey, can I subtract the upper bounds? Of course. 144 minus 139 is 5. 149 minus 144 is 5. So it must be the same for all of them, for lower bounds and also the upper bounds. The midpoint of the first class, 135 plus 139 divided by 2, which is equal to, well, 274 divided by 2, or just 137. It needs to be in the middle of 135 and 139. This is the midpoint of class number 1. And finally, the boundary for the class 1, shift to the left, shift to the right, half a point, half a unit. So if you shift 135 to the left, you get 134.5. And if you shift 139 to the right, you get 139.5. So as you can see, the answer is A. Let us go to the next page. In page 4, what do we have? Well, in page 4, question says, okay, find the mean, median, and mode of the data. Okay, so let's use our calculator to find these. The best way to calculate these is to use our calculator. Remember that for the exam, you need to use your calculator. Make sure you have it with you. So would you able to use it again? Yeah. Of course, of course. So Let's see. These are the numbers, the data that we have. Let's move this a little bit up. So calculator as well. There you go. So to use your calculator to find the mean, you can also find the median. Remember that the median was the second quartile. So click on Stat, go to Edit, and enter all of these values. So let me just click everything, put them all. I'm deleting everything that I have on L1, and I'm going to enter all of these numbers. So go to Stat, go to Edit to enter the data. So the first one is 65, enter 68, enter 61, enter 65, enter 58, enter 66, enter 65, enter 59, enter 60, enter, and 63. Very good. Now we go back to Stat, we go to Calc. So now Stat, then Calc. When you go to Calc, you select the first one variable statistics, one var. Okay, let's enter that. We entered everything in L1. We make sure our column is correct. And then here we go. What do you see here? You see X bar, which is equal to 63. So this is our mean. X bar is 63. What about the median? Let's go further down to find the median. Q sub 2 or median is 64. Median is 64. Well, do we see mode? Which number is repeated the most here? Well, 65 is repeated 3 times, 1, 2, 3. So mode is 65. Next question says, well, the top 14 speeds in miles per hour for cross-stock drag racing over the past 2 decades are listed below. Find the mean speed. We have these information. We're going to follow the exact same process. Stat, edit, enter the values in L1, and then Stat, calc, variable statistics. The same process. We can use a different column as well. So let's take a look at this. Let's clear the whole thing. Let's go to Stat and then go to Edit. You can go to L2 instead of L1. So now I am in L2. I'm going to enter these numbers: 181.1, 202.2, 190.1, then 201.4, then 191.3, then 201.4, then 192.2, then 201.2, then 193.2, then 201.2, 194.5, 199.2, 196.0 or just 196, 196.2. So I'm using L2 instead of L1. Take a look at this. I go to Stat, I go to Calc, variable statistic. I enter. I don't have information in L1. I have information in L2. click on second 2. So second 2, change your column to L2. So let's go further, calculate, very well. So as you can see, X bar is 195.8. This is my X bar for the mean. So for the rest of them, like question 4 and question 5, the process is the same. If you follow the process by plugging the values in any column, going to stat, going to edit, use L1, L2, L3, any column that you like, then go to stat, then go to calc, and one variable, you can find the values or the characteristic that is required from you. It says, hey, find the mean and find the median. If you use your calculator, the mean needs to be 97, and the median or Q2, the median is 35.5. For number 5, the same process. Your mean is going to be X bar is going to be 37, and the median or Q2 is 35.5, which are very close to each other. Here, question says, write the word or phrase that best completes each statement or answer the questions. Provide appropriate response. Question says, here, you need to purchase a battery for your car. There are 2 types of battery available. The first type has mean life of 5 years. So we're going to write this down here. Type A has mean life 5 years. 5 years. Standard deviation is 1 year. And standard deviation is just 1 year. You have type B. In type B, well, the mean life is 5 years. X bar is 5 years. And the standard deviation is 1 month. 1 month. So standard deviation is 1 month. Very good. So both batteries cost the same. Which one you select? Here. What's the best way to select the battery? How do we use this? They both have the same mean. It means that the balancing point is the same. But how do you select these two? One of them has standard deviation 1 year. The other one has standard deviation 1 month. Well, which one has less variability? Which one has larger variability? And which one is more reliable? That's the question this guy is asking. Which one is more reliable? So it's less likely the battery B to fail before its mean life. So B is more reliable. B is more reliable. Less variation. Standard deviation is just 1 month. Well, question 2. Here are the batting average of Sammy Sosa and Barry Bonds for 13 recent years. Which player is more consistent? Consistent, it means that you're dealing with less variability, more consistent. So first we need to find the standard deviation of the first set. Then we need to find the standard deviation of the second set. How do we find the standard deviation? To find the standard deviation, the process is the same. We go to edit and stat. We enter the data. Then we go back to stat, calc, one variable statistics. So let me show you one of them. Then we're going to just write down whatever we have for the second one. Okay, so over here. So we can see our calculator. Very good. Let us turn on the calculator, clear the whole thing. So let us go to stat, edit, and enter Sammy-Sosa information, the data in L3. So we have 0.203. Then we have 0.260. Then we have 0.261. We have 0.3. We have 0.268. We have 0.273. We have 0.251. We have 0.308. We have 0.288. And then we have 0.320. We have 0.328. We have 0.288. And we have 0.279. Very good. Now go to stat, go to calc, one variable. It's not L1, it's not L2, it's L3. So second 3, it gives you L3. Now your standard deviation is equal to 0.30. I can say that, hey, you're working with every information here, so your standard deviation can be standard deviation of the population, 0.32. So this guy is 0.32, the standard deviation for the first one. The standard deviation for the second one, so we're going to calculate the standard deviation. Let's see. Very good. You can enter this information again in stat. Just going to calculate the whole thing. Now I'm going to use L4, 0.292, 0.311, 0.336, 0.312, 0.294, 0.308, 0.291, 0.303, 0.262, 0.306, 0.328, and 0.370, and finally 0.341. There we go. So let us go back to stat, go to calc. Now we need to enter information from L4, so second 4, and then we have these. So the standard deviation is 0.026. Yes, this 0.026. So which one has less variability? The second guy has less variability, smaller standard deviation. So standard deviation of bonds is less than the standard deviation of Sosa. So bonds is more consistent. Less variability. Number 3, you are the maintenance engineer for a local high school. You must purchase fluorescent light bulbs for the classroom. Should you choose type A with mean 3,000 hours and standard deviation 200, or type B, which would mean 3,000 hours and standard deviation 250 hours. Which one is more reliable? Which one is more consistent? Type A or type B? We are interested in less variability or more variability? Less, very good. So which one has less variability? 250 or 200? 200, since standard deviation of type A is 200, and it is less than the standard deviation of type B, which is 250, it means that type A has less variability. It means that it is more reliable. Let's take a look at page 6. In page 6, question says, hey, use the data to identify any outliers. Outliers, okay. Let's take a look at the data. This is the data that we have. We can also use our calculator. Let me show you. Use your calculator. You need to enter the data that you have. So let us go to, just clear the whole thing. Let me go to second, plus, and start erasing everything that I have. Reset the whole thing. So enter all ramp. And then again, second, plus, go to reset and reset all defaults. Okay. Now I'm going to enter all of these information in L1. The same process. Stat, edit, 15, 18, another 18, 19. I have 22, 23. I have 24. I have another 24. I have another 24. I have another 24. I have 25. I have 26. Another 26, 27, and then 28. Well, another 28. Then I have 30. Then I have 32. I have 33. And then I have 40 and 42. Okay. So let's see. Now, let me check. We go to second, we go to graph, just graph. Let me see. This y equals to, so second, y equals to. So we click on second, forgot the order, second, y equals to. Then you click on the first plot. You turn on the plot, so enter, go to the type. Here you have different types of graphs, like histogram, like box plot. The first box plot helps you to identify outliers. So click on that. All information are in L1, and then let's see, graph, zoom, 9, very good. So second, y equals to graph, zoom, 9. It gives you the box plot. As you can see, these two dots, these two numbers, which are represented by 40 and 42, are our outliers. You can just move a little bit and see where are we. Just go to those numbers. These are the numbers that we have. 40 and 42. Number two says, well, a test score of 30 students are listed below. Draw a box and whiskers plot that represents the data. Here, you're going to use the same process. You're going to enter the data in L1 or L2 or L3. Then you're going to go to second, y equals to graph, zoom 9 to create the box plot. So in this case, if you want to find the box plot, you need to know what is your minimum value, just using hand. Your minimum value in this collection is 31. What is the maximum value that you have? The maximum value, they are written in order, is 99. You need your Q1, you need your Q2, and you need your Q3. You can use your calculator to find the first quadrant, the second quadrant, and the third quadrant. Okay, very good. So how do we find those? Entering these numbers in our calculator and then find these. It gives us 56, it gives us 72, and also 83. As long as you have minimum, maximum, and all of these numbers, which we call 5-number summary, we can easily graph our box plot. So this is the minimum value, 31, the maximum value near 100, which is 99. So this is the line connecting the minimum value and the maximum value. If you don't want to use your calculator, you can just graph this. The first Q1, let's take a look at the median. The median is 72. 72 is roughly here. So you have your 72, which is your median. Well, Q1 is 56. 56 between these two. Let's see, it's going to be roughly here. 56. And then you have your 83, which is here. So remember that Q1 and Q3 are forming the sides of the rectangle, and then your median, which is 72 or Q2, divides this box into two pieces. So this is your box plot approximately. To get a better graph, you can use your calculator or use any online website. Okay. The same process here. So we need to find the minimum, we need to find the maximum, we need to find Q1, Q2, and Q3. The minimum value is 154. Luckily for us, everything is written in order. The maximum value is 265. Then Q1 is 180, Q2 is 196.5, and then Q3 is 211. So the minimum value is 154. So 154 is here, and the maximum value is 265. Okay, very good. Very well. So the median and Q1, Q3, if you want to think about this, it's just going to be shifted a little bit toward here. So let's suppose this is 200 in the middle, 200, and a little bit further, 196.5, and then 211 is going to be here, and the other guy is 180. 180. So you have your sides for your rectangle, and this is your box plot.